Jones Geometry 1.1 Sets. In this lesson, we are going to be learning how sets relate to geometry. Sets can help us visualize, explore, and analyze mathematical relationships between different geometric objects. Sets are typically named with a capital letter and designated using braces. Objects in a set are called elements, or members of the set. Sets can be described by listing the elements, stating the rule, or using the set builder notation, which is written here. It's pretty much saying C equals the braces that we just talked about, X such that, that's what this symbol means, such that is a letter in complement. And of course, remember, X's are variables. So a variable is a letter in the word complement. Stating a true fact is a set builder notation. The symbol E means is an element of. A set containing with no elements at all is called an empty set or null. And it's notated by either the braces, an empty set of braces, or the circle with a line through it. Let's take a look at an example so you can see what a set builder notation actually looks like. Example 1. Describe set P pictured above using both list and set builder notation. You remember, when learning a new lesson, make sure you have your book open to the page of that lesson. 1.1 is on page 2 in your book. At the top of example 1, you see a picture of phone accessories. And it wants to know two separate things in this question. Describe set P pictured above using both the list and the set builder notation. A list is simple, so let's make a set of just a list of the stuff that's at the top of page 2 in your book. A list. So we're going to put P, because it's phone accessories, equals a bracket, and let's take a look what's listed, what's pictured on this page. I see earphones, a charger, a phone case, a screen protector, a battery, an auxiliary port, and an armband to carry a phone. So that is a good list. So that's what we put in this first set, the list. That creates my list set, the very first thing it wanted in the equation. Now the second thing it wants is the builder notation. The builder notation literally describes exactly what's showing. What's showing in the picture on page 2 at the top. Phone accessories. So that is exactly what the second set's going to be. P equals braces X such that X is one of, let's give it a name, Liam's cell phone accessories. And that's the answer to this example. We found the list And we created a set builder notation. Let's continue. Here are a few notes you need to know. Equal sets, subset, and proper sets. Definitions. Let's take a look at equal sets first. Equal sets. It has an equal sign because it's equals. The definition of equal sets is sets containing the same elements. Sets contain the same elements. And let's take a look at examples. A equals C. But let's go ahead and take a look at C before I can explain this example. C equals X such that 0 less than X, which is less than 10, where X is an odd integer. So before we can actually answer the subset, find the equal sets of these three sets A, B, and C, we have to figure out what C is first. So 0 is less than X, which is less than 10. That means all the numbers that are odd integers between 0 and 10, which would be 1, 3, 5, 7, and 9. So if we're looking at the equal sets, which is sets contain the same elements, you see that A and C equal each other, which makes our example here for equal sets A equals C. Subset. Here is a symbol for subset. The definition for subset says every element in B is also in A. So it's pretty much saying that you take a look at all your sets and see if any of one set is in a different set. They don't equal, but it includes it. So if you take a look at B, you see that the numbers in B, which is 3 and 7, is also in A, which is 1, 3, 5, 7, 9. And you see that B is a subset of A, and we also see that A is a subset of C. Although they equal, it still is a subset. That means B is also a subset of C. But because B is a subset of A, we could use A instead of B for the C. Let's take a look at a proper subset, which here's a symbol for proper subset. The easy way to describe what a proper subset is by showing you this answer. B is a subset of A, but B does not equal A. So a proper subset is the opposite of equal to. B, the numbers in B are included in A, but B does not equal A at all. And we cannot say A is a proper subset of C because A and C are equal, which causes the problem. Now we could say A is not a proper subset of C. That works because what's the opposite of not equal? Equal to. Here are a few more symbols we need to learn. The first dot means not equal to. The equal sign with a line through it means not equal to. Next dot, E with a line through it, not an element of. The third dot, not a subset of. The line should be there. It's not a subset of. And the last dot is not a proper subset of. Now that we've learned all those symbols, let's take a look at the next example. Example 2. Given A equals 1, 3, 5, 7, 9, B equals 3 and 7, and C equals X such that 0 less than X, which is less than 10, where X is an odd integer, which is, we already found out that the numbers for that set would be 1, 3, 5, 7, 9. Determine whether each statement is true or false. Statement 1. The set of 1 is an element of A. The answer is false. The set of 1 is not an element of A. But why is it not an element of A? It's because both 1 is an element of A, but the problem is the set of 1 is also a subset of A. B. A is not a proper subset of C. We've already determined that C is 1, 3, 5, 7, 9. Proper subset of. Now remember, a proper subset says they can't be equal. What's the opposite of can't be equal? They have to be equal. If proper subset says can't be equal, that means the opposite of non-proper subset is opposite of that. So it means it can be equal. Does A and C equal? Yes, so this is true. While A is a subset of C, it is not a proper subset because A does equal C. C. B is a proper subset of C. Remember, we already figured out what C is. Let's go ahead and write it here. 1, 3, 5, 7, 9. It wants to know if B is a subset of C. Remember, subset means it can be a proper subset of C. If to be a subset of C, that means they can't equal at all. Does B and C equal? They don't, because we have 3 and 7, but 3 and 7 is a part of this set, but doesn't equal that set. So the answer is true. All the elements of B are in C, and also B does not equal C, which is the second half of that definition. And the last one, D. B is a subset of null, of nothing. B is a subset of nothing. Is this true or false? Remember, let's remember what null actually means. It's something that has no numbers in its set. Is B a subset of nothing? False, because neither element of B can be found in an empty set. 3 or 7 cannot be found with a circle with a line through it. There's no way those two numbers, 3 and 7, fit in null because it's an empty. So it cannot be a subset of it. Let's talk about something that we learned in algebra. The universal set U contains all the elements within the context of the problem. Equivalent sets are sets that have the same number of elements, a one-to-one correspondence. The U right here pretty much means it's everything combined, every single number inside of all the sets. Here's a good look of your U's. You have U, which shows you A and B inside of U. So any numbers that are in A and B is part of your universal set. Same thing, the second box, G and B, Heather and Jack, the girls and boys, Rhonda, Fred, Joy, Ron. These are your sets. A union of A and B, denoted AUB, denoted pretty much means union has a symbol that looks like a U, is a set combining all the elements of the given sets. That means any number that is in A and B, you make a set of it. Intersection of A and B, denoted A intersected B, which here's the symbol for intersection, it looks like an upside down N, is a set of elements containing numbers that match in A and B, or the elements that are in common in both sets. That is your intersection, which is right here. Now we have the complement of A, which is written like this, with a comma at the very top of A, which means is a set of all the elements in the universal set that are not in A. All the numbers that are around A but are not in A alone. Here is a good way to show you what each of these mean. We talked about the union. The union is all the numbers given a part of that certain set. So we have A and B, all the numbers that are in A and in B. That's why it's colored in blue. The intersection is all the numbers that are part of A and B. Any numbers that include or match in A and B. That's the reason why where two circles cross, in the middle of that blue is shaded, because the numbers that are part of A and the numbers that are part of B would be in that section. For example, if I have 2, maybe 2, 1, 4, 3, and 6. The 6 is what matches between A and B. The 4 is what matches between A and B. So that's why the 4 is in the middle, and that's why it's actually shaded, because it intersects between A and B. And the complement pretty much says any number on the outside of A is your complement. Let's do an example. Example 3. If R equals 1, 2, 3, 4, S equals 1, 3, 5, 7, and U equals X such that X is a single-digit natural number, find the result of each set operation. A. R union of S. Union of S. So when we're actually thinking about the union means it's all the numbers that are in R and S. So, which will be what? Create our set by using braces. 1. Now, because 1 is an R and 1 is an S, we only write it once, not twice. 2 is an R. 3 is an R and S. 4, 5, and 7. That is a union of R and S. Let's continue. All right, let's take a look at B. B is R intersecting with S. Intersecting is numbers that match. Do you see numbers that match? Very good. 1 and 3 are numbers that match because here are numbers that match. Let's continue. In the very last example, it wants the complement of R. The complement of R. The complement of R, the complement is all the numbers they're not in R. Any and all the numbers that are not in R. So let's go ahead and circle all the R numbers, which is 1, 2, 3, and 4. So any numbers that doesn't include 1, 2, 3, and 4, which numbers in S will work. 5 and 7. What about the numbers in U, which is X is such that X is a single-digit natural number. Single-digit natural number. A natural number starts at 1 and goes up, and it wants all the single-digit numbers, which is, here's a good way to write it out. Single-digit natural number, the very first one is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it's single digit. 10 doesn't count because 10 has 2 digits. So that's all the single digits, natural number. So what number of the U's needs to go down here, which is the complement of R, which means all of R's can't be used. Which we already said 1 through 4 is R, so all the numbers is not 1 through 4. We need 6. We already put 7, 8, and 9. It's all the numbers that aren't touching inside of R. If you take a look at this box right here, when we shade it, we would shade everything but R. So there goes 9, there goes 7, there goes 8, there goes 5, there goes 6, and then there goes all the numbers that are not touching R. That is the complement of R. The very last thing we're going to talk about are different types of operations. Binary, unary, and disjoint sets. Binary operation is applied to 2 sets, unary operation applied to only 1 set, and disjoint sets are sets having nothing in common at all. Let's take a look at an example. Example 4. If R equals 1, 2, 3, 4, S equals 1, 3, 5, 7, and U equals X, that is X, a single-digit natural number, which we already talked about those numbers, which is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Find each set and draw a Venn diagram illustrating the operations. So A is the complement of R intersects with S. Because we have no idea what the complement of R actually is, let's write that underneath the complement of R, just so we know how to find the intersect of S. The complement of R is all the numbers that does not include R, which will be, can't be 1, can't be 2, can't be 3, can't be 4. So it'd be 5, 6, 7, 8, and 9. And of course we have S right here. What numbers intersect? What numbers match? 5 and 7. That is the set of numbers that the complement of R intersects with S. Now let's take a look at the Venn diagram. Over to the right, you see the graph that's already been created. So let's go ahead and put the R, what numbers would go in R, which is 1, 1, 2, 3, 4, completed. And why did I put 1 and 3 in that certain little oval section where R and S are? Because that's where they combine. That's the one that intersect between those two. That's the reason why we had to make them in that awesome circle. Now our S's, we already put 1, we already put 3, let's put 5 and 7. And of course the U equals, the U is the big box, which means it's any number that does not match with R or S. So you have 1, 2, 3, 4, 5, 6, we have 7 already, 8, 9. Now, when we look at our answer, we have 5 and 7. So we would shade where the 5 and 7 is located, which is where the S is, which is a spot that's already been shaded. So all in here is a shaded spot. All in here is our answer, 5 and 7. So inside this S, not where it connects here, but only in this shaded spot where the 5 and 7 are located. Example 4b, the complementary of R intersection of S. Before we define the complementary, let's go ahead and get the intersection first, which will look like this. Here's my R, here's my S. Then intersection is the one that matches, which is what? 1 and 3. That matches. But it doesn't want the intersection. It wants the complementary of the intersection. It wants all the numbers that's not 1 and 3, which is 2, 4, 5, 6, 7, 8, and 9. Don't forget that we have to also include the U, which is we talked about before, was 1, 2, 3, 4, 5, 6, 7, 8, 9. We saw that 1 and 3 were intersections, so those don't count, but the rest of them do, which is my answer. Now, it wants us to go ahead and shade these numbers that are given. But if you notice that the 1 and 3 is the intersection, that means don't shade the 1 and the 3, but everything else we can, which happened in this Venn diagram. The 1 and the 3 are right here because they intersect. Everything on the outside are all the numbers that do not intersect. which gives us our answer. If you guys have any questions, make sure you find me. I'll answer them. You have a good night.